Hi everybody, this is our final review for the semester, and then I'm going to email out your final to your parents by tomorrow morning. I'm not sure there'll be 15 or 20 problems, but I'm going to try to make them pretty basic. I just want to make sure you have a grasp of the most important concepts from the semester that you'll need going forward. So let's get started. The first thing I want to go over, do you remember in class when every day at the start of our class we would start with a large number and I would ask you to read it to me because you'd be surprised how many people cannot read a large number. And I want to make sure that you guys know how to do it properly. All right, we haven't done that in a while. We haven't met in person in a while, so I'm going to do it again for you here. But instead of us doing it together, I'll just do it by myself. Okay, so let's see, what do we have here? We have millions, trillions, and millions, billions, and trillions. I think after trillions is quadrillions, but we'll just go up to trillions. Okay, so remember I showed you, or I taught you, to read a large number, you just say your packet of 3 numbers, just read it like you'd read any 3-digit number, and then say the place value. So to get started, we'd say 745 trillion, 209 billion, 3,091,501. All right, let me read that again. 745 trillion, 209 billion, 3,091,501. And by the way, when you're reading a large number with no decimal, you never say the word and. I might have said 501. I didn't mean that. The only time when you're reading a number and you hear the word and, that means decimal. That is the only time you say an and, is when there's a decimal. All right, I just wanted to review that. We haven't done that in a while. I miss reading our large numbers together. Okay, now I want to write a large number and I want to review rounding very quickly. Right, 532, 343, let's see. All right, so first I'm going to give you a large number. We're going to read it correctly, and then I'm going to practice rounding to a few different place values here. Let's read this large number together. Not together, what am I saying? I'll read it to you. Hopefully you'll be reading it along with me at home. All right, like I told you, okay, this number here has a decimal. We're going to say and when we get there. All right, 532,343,090 and 2,314 10,000ths. I almost forgot what place value that was. So to read a decimal number, you read the number just like you're reading any whole number. This is 2,300. There I did it again. I said and 2,314. That's 2,314, and then we say the place value, and this is tenths, hundredths, thousandths. This is 10,000ths. So once again, 532,343,090 and 2,314 10,000ths. All right, now that I've read that correctly, I want to go over rounding. Okay, so remember that video early on, sometime in the first couple of classes that we had, who's that knocking on my back door? I kind of like that little jingly rhyme, so we're gonna do that. It's gonna help you remember how to do these rounding problems correctly. All right, let's try. I'm using red and green today as my accent colors in honor of Christmas. All right, let's say I want to round this number to the nearest 10,000. 10,000ths place. Not 10,000th with a TH, but 10,000ths place. And that's here. This is the 10,000ths place. This is ones, tens, hundreds, thousands, 10,000ths. So remember, I look at the number I want to round to. And I put up a wall or a door. Put up a door right after that number. And we say that little jingly rhyme, who's that knocking on my back door? 5 or more, raise the score. Who is that knocking on the back door? It's a 3. Is it 5 or more? Nope, it's not 5 or more, so we leave it 3. Once I've determined, we leave our 4 of 4. If that were 5 or greater, we would round our 4 in our 10,000ths place up to 5. since it is less than 5, we leave our 4 at 4. Once I know if I have to round my 4 up or leave it at 4, now every other number after that is going to be a 0. Leave it at 4. I'm rounding to this place here, so every number after it will be a 0. And I mean, I guess I could put a 0 there, but I don't need to. It's already understood. So when I round to the 10,000s place, I get 532,340,000. And that's my answer. Now I want to round to a decimal place, right? So let's use the color blue, and I want to round to, the hundreds place, which is right here. So I want to round this whole number to the hundredths, the TH, hundredths place. Okay, so once again, I put up a door right after the place value I want to round to. I look at the number that's behind the door, and I say, who's that knocking on my back door? 5 or more, raise the score. Once again, it's less than 5, so my 3 stays 3. So let's rewrite this number rounded to the hundredths place. It's 532,343,090 and 23 hundredths. Everything after that's a 0, and you don't have to put zeros. You don't have to put trailing zeros in a decimal number. All right? And that's how we round. Remember, 5 or more, raise the score. I'm going to do one quickly because I didn't have any that rounded up. So just to do this super simple, 5,392. Let's say I'm rounding to the tenths place. Scratch that. I'm rounding to the hundreds place. The hundreds place. Okay? Rounding to the hundreds place. So let's put a door up. And we say, who's that knocking on my back door? 5 or more, raise the score. Okay? Who's that knocking on my back door? It's a 9. That's 5 or more. So I'm going to raise the score. I'm going to raise my 3 to a 4. And so when I round it, it's going to be 5,300. Everything after the door becomes a 0. And I look at the place value I'm rounding to. If the number behind the door is 5 or greater, I raise that up. Boy, I'm really flubbing here today. I'm trying not to stop my video and go back to the beginning. 5,400. Okay, next semester, there's big prizes for when you catch me mistakes on the video, okay? All right. I'm going to clear my screen here. Let's get rid of all that. Okay. Adding and subtracting decimal numbers. I want to go over decimal numbers, right? When we add and subtract decimal numbers, we have to line up our decimal in our problem. So if I wanted to subtract, if I have the number 5,342 and 1/10, and I want to subtract 972 and 57 hundredths, I would have to line up that decimal, and so I would write it like this. And so I'm lining up my decimals like so. Well, this means in my second number, I go out to the hundredths place, but in my first number, I only go out to the tenths place. I need to add a 0 placeholder there, so I have enough decimal numbers to do my subtraction. All right. Please, when you see these numbers here, don't say 7 minus 0 is 7, or don't forget to put this number in, and then just go ahead and, drop down a 7. Don't do that. You have to put that 0 in there, and you have to borrow, okay? So now we can just simply subtract this. So we're going to have to borrow here. It becomes a 0, this becomes a 10. 10 minus 7 is 3. Again, I have to borrow here. becomes a 1. This becomes a 10. 10 minus 5 is 5. My decimal stays in the same place. Oh man, I didn't mean to have to borrow all the way through. 11 minus 2 is 9. Okay, 13 minus 7 is 6. Well, let's keep things consistent. Okay, 12 minus 9 is 3, and then I do drop my 4 down. My answer is 4,369 and 53 hundredths. Okay, and that is important to remember. When you add and subtract decimal numbers, line up your decimal. If you need to put in filler zeros, go ahead and do that. Don't just drop down that last digit 7. That's going to be wrong. Okay? Very important. Line up the decimal for adding and subtracting. Okay. Now everybody's favorite problems, multiplying and dividing decimal numbers. Okay? I'm going to do both of these type of problems because I want to make sure you have them right. All right, let's start with multiplication. All right. When I multiply decimal numbers, I do not have to line up my decimal. Don't worry about your decimal until you have your final answer when you'll put your decimal in. All right, for starters, we just write our two numbers down and we do our multiplication as any standard multiplication. So I'm going to start with my ones place in my 8.2 here. 2 times 1 is 2. Let's go through and do this quickly. 4, that's 5, and 14. Let's put in our 0 placeholder. Let's go to our 8. Right? 8 times 1 is 8. 8 times 9 is 72. So much nicer when you know your times tables. 8 times 2 is 16, plus 7 is 23. Put down the 3 and carry the 2. 8 times 7 is 56, plus 2 is 58. Do make sure you line up these numbers in the proper columns. It's so easy to make a mistake. If you write too small or too faint, make sure you always have enough room to work your problems when you're working on your page. All right, then we just add them. 2, 6, carry the 1, that's 8, 7, 9, 5. Now that I'm done, I go back to my original two numbers, and I see that this number has 2 digits after the decimal, and this number has 1 digit after the decimal. I add those up. 2 plus 1 is 3. That's how many decimal places I need in my answer. So starting here, I count 1, 2, 3. I start at my rightmost digit, and I count 1, 2, 3, and that's how many decimal places I need in my answer. So my answer is 597 and 862 thousandths. All right, that's decimal multiplication. Not hard, just multiply as you would any numbers and then add your decimal at the end according to how many decimal places are in both of your factors. Okay. Let's do quick decimal division. All right, let's see. Let's say we have, excuse me, 34 and 2,426 10,000ths divided by 2 and a tenth. 2 and 1/10, I should say. In decimal division, okay, we never want to divide by a decimal number, so our divisor right here cannot have a decimal in it. We have to move it to the end, and then however many decimal places that ended up being, we do the same thing in our dividend, right? So this will become 342 and 426 thousandths divided by 21. Right? Get that decimal moved. Right, now we can divide. 21 goes into 34 one time. That's easy. That's 21. 34 minus 21 is 13. And we drop down our 2. 21 goes into 132 6 times. 6 times 21 is, I think it's 126. Right? When we subtract, that's 6. And my next number to drop down is a 4, but I have to deal with my decimal. I run into my decimal, I stop, I put it in my answer before I can go on. Can't do anything with that 4. Can't get to it until I put my decimal up in my answer. Now it's there, I can drop down my 4. 21 goes into 64 3 times. 3 times 21 is 63. 1 left over. Drop down my 2. 21 goes into 12 0 times. And that's 0. Oh, let's see if I can squeeze this in. 12 minus 0 is 12. Drop down my 6. As you can see, I have 126 here. It's going to go in nice and evenly 6 times. And then I will be done. I'm going to squeeze that in. And it's a 0. No remainder. All right. So I shouldn't say no remainder. I should say it divides in evenly, and we finish at 16 and 306 thousandths. So that's decimal division. Okay. What's next? Oh, what have I got here? Okay. Before I go on, I want to remind you of the rules of divisibility. This is really helpful when you're reducing fractions and you want to find out what number goes into both your numerator and your denominator. Let's say you have a large number, you have 100 over 150. Those are easy numbers. And we know, 10 is going to go into both of them. Let's say, actually I think 50. 50 is the biggest number that will go into 100 and 150. But let's say we have a number like 342. And we need to see if we can divide that, and then let's say I'm going to make this easy, our denominator is 684. I've just doubled it. Oh goodness, where do I start reducing this? I can just start dividing top and bottom by 2, but let's remember the rules for divisibility. If I add up the digits in any number, okay, in this case 3 plus 4 plus 2 is 9. If this number 9 is divisible by 3, then this is divisible by 3. So I can know that 3 goes into this number. I'm going to guess it's, let's see, 6 and 8 is 14, and 4 is 18. So we know that 3 goes into that number. Okay, that's obvious because I doubled 342. So the number 3 divides into 342 evenly. We know if it ends in the digit 2, in an even digit, that's in any even number divides obviously by 2. Let's go one step further. If a number digits, when you add them up, if they can be divided by both 3 and 2, then the number is divisible also by 6. So let's look at this. 3 plus 4 is 7 plus 2, that's 9. I just did that. Now, 9 is divisible by 3, but 9 is not divisible by 2. Not divisible by 2. So this number is not divisible by 6, but it is divisible by 3. Let's look at the number, let's try the number 641. 6 plus 4 is 10, plus 1 is 11. Okay, 641 is not going to be divisible by 3. It's not going to be divisible by 6, and it's also not divisible by 2 because it's an odd number, because it ends in 1. All right. Let's try the number, what else have I here? Let's try the number 351. 3 plus 5 is 8, plus 1 is 9. Oh, there's another one that adds to 9. Okay, we know that's divisible by 3, but not by 2, because it ends in an odd number. Let's see. However, if it were, let's see. What if I made this a 4? I made that a 4. Now I have 3 plus 5 is 8, plus 4 is 12. Now they add up to 12. Well, 12 is divisible by 3 and by 2, and so we know this number is divisible by 6. I'm just reminding you about the rules for divisibility because they do help out when we get to fractions, when you have to reduce. So remember that. If you add the digits and they are divisible by 3, then the number itself is divisible by 3. If you add the digits and they're divisible by 2 and 3, that number is also divisible by 6. I just wanted to stop off there for a second before we get into fractions and reducing. All right, I want to remind you about factor trees. You'll need to know how to do a factor tree. Okay, they're very easy. Break your large number down into its most obvious factors. I think here it's probably 49 and 100. And again, if you know your multiplication tables, this gets pretty easy. 7 times 7 is 49. 7s are both prime numbers, so I'm done on that branch of my tree. Let's go to 10 times 10. We know that's 5 times 2 and 5 times 2. Now let's order all of my primes. I'm done. I've gotten to primes on all of my branches. And let's order them in number. Order them by number, I should say. I have 2 2s, so I'll say 2 times 2. I have 2 5s. And I have 2 7s. And this is called my prime factorization, right? Making 4,900 into a product of primes is what they call it. A product of primes. Sometimes they'll ask to write it with exponents. So I would say 2 squared times 5 squared times 7 squared, because there's 2 of each number. So when I multiply 2 by 2, I'm squaring it. 5 times 5 is 5 squared. 7 times 7 is 7 squared. So this is making 4,900 into a product of primes using exponents. They sometimes ask for that. All right, I'm going to do one more quick factor tree of a large number. Let's try, I'm going to pick one off the top of my head. Let's try 3,982. I didn't do this one in advance, so let's see where we get. So what I like to do is, I know that it's an even number, I'm just going to divide it in half. Let's see, 1,500, 1950, 1991 times 2. Let's see. I'm going to scratch this number. I didn't pick a good one. Just not going to make it difficult. I'm going to do 2,568. That's easier, I think. All right. Once again, it's an even number. Let's start by cutting it in half. Half of 2,500 is 1,250, and half of 68 is 34. So that's 1,250 and 34 is 1,284 times 2. And I'm just going to keep breaking these in half until I get to a lower number and I can see more clearly what my final primes are. Half of 1,284 is 642. Keep going. Half of 642 is 321. Now, 320 is not an even number. I can't divide that in half anymore. So let's add up the digits. 3 plus 2 is 5 plus 1 is 6. Okay, this is divisible by 6. Let's see. I'm going to start with dividing by 3. That's easier. It's also divisible by 3 because it adds up to a number that's divisible by 3. So, let's see. So I'm going to say 3. That's 107. 107. That might be as far as I can go. Let's see, 20. It's 7 and 1 is 8. It's not divisible by 3, not divisible by 6, not divisible by 2. All right, that was a funny number. So I'm going to say we're stopping there. It's probably not a prime, but I'm not going to waste your time by figuring it out right here. If you guys can figure out if 107 breaks down into 2 other factors, you go ahead and do that for me. 2 times 2 times 2 times 3 times 107. And that's my product of primes. Okay. So know how to do factor trees. Okay. And remember, okay, if you should know this by now, a prime number is a number whose only factors are 1 and itself. That's it. Those are the only numbers that go into it evenly. So for example, the number 17. It doesn't break down to 2 or 3 or 6 or any other factor. Its only factors are 1 and 17, and that's the definition of a prime number. Okay. All right, moving along. Let's do a review of least common multiple. This is important for when we get to common denominator. The common denominator and the least common multiple are the same thing. Denominator, okay? They teach you how to find the LCM, which means least common multiple, but that's going to be when you get to fractions and you have to find a common denominator, it is the least common multiple. So for example, let's just take two numbers. If I have the number 8 and the number 12 and I want to find out what is the least common multiple, one method I can do is just list all the multiples of 8, and I can just keep listing them until I get to a number that's common in both lists. These are smaller numbers, so I'm going to hit the least common multiple pretty quickly, and we can see it's 24. But if I have larger numbers, you don't want to be listing all the multiples. So let's say I have the number 39 and the number 72. You're not going to want to start listing multiples of 39 and 72 to find out what your LCM is. So the other way you can do it is breaking your two numbers down into primes. So let's come over here using a factor tree. Right, 39 breaks down into 13 times 3, and those are both primes. 72, on the other hand, breaks down into, I'm going ahead of myself. 9 times 8. Okay. And this is 3 times 3. Okay, so 39 is 13 times 3, and 72 is 2 times 2 times 2 times 3 times 3. The way that I find the least common multiple by looking at the product of primes for both numbers is I have to circle the greatest occurrence of each prime that I see in the two lists of numbers. So I have a 13, I need that. I have 3's in both lists, but I have 2 3's in this list, so I need those 2. And then I need these 3 2's. I need to circle at least one set of each prime that I see looking at the two lists, and I need the greatest occurrence. So now I will have to multiply them. I've circled all of my factors of 72. So I know that I have 8 times 9. I have 8 times 9 times 13. That's a pretty big number, okay? 8 times 9 times 13. That's going to be my least common denominator for 39 and 72. It's going to be 72 times 13. And that's big. 936. That's how we find the least common multiple for larger numbers. Break them down into primes and circle the greatest occurrence of each prime that you see in the list. Okay, then just remember that for later when we're going to find common denominators. Actually, we're there now. We're going into fractions right now. Okay, so I would really, really like you to master how to add and subtract fractions and how to multiply and divide fractions. This is super important going forward into algebra, okay? Everybody needs to know how to manipulate fractions. So let's start with the fractions. I'm going to start with an addition problem. 1/12 plus 3/8. So my first job is to find the LCM of 12 and 8. We just did that, and I showed you that it's 24. So if I were to write my multiples out, or if I would do it by the product of prime method, I would find that 24 is the lowest number that 8 and 12 both go into evenly. That's what we need. The smallest number that both denominators go into evenly. So I always tell you, write what you know. Both denominators are 24. We can't change our denominator without changing our numerator. I multiplied 12 by 2 to get to 24, so I do that to my numerator. In the second fraction, I multiplied 8 by 3 to get to 24, So I do that to my numerator, and that's 9. So please, when you add fractions, only add your numerators, 9 and 2. Do not add your denominators. The denominator does not get added. It stays the same. Okay, add numerators. Oops, sorry, let's start with step 1. Find a common denominator. Change your numerators and add your numerators up, and that's how you add fractions. Okay. It's the same process for subtracting fractions, right? I won't go into that. Now I want to work on multiplying and dividing fractions, which I actually like a little better. All right, let's start with 15 over 21. And I'm going to multiply that by, what did I have here? 9 over 30. All right, to multiply fractions, all we do is multiply the numerators and we multiply the denominators. But once you get that done, you're supposed to reduce it to its smallest term. And if I were to go ahead and multiply 15 times 9 and write the answer here, and multiply 21 times 30 and write the answer there, those would be very large numbers, and then I just have to go ahead and reduce them. So the way that you get out of that reducing large numbers is to cancel first. Oh, goodness. Okay, let me write that back in. Okay, so the way that we cancel when we're multiplying fractions is we go ahead and we break down our numerators and our denominators into a couple of factors. Just start with any, it's going to turn out the same. You'll get the same answer. Like here, if I did 15 times 2 or if I did 10 times 3, I'm going to end up getting to the right answer. I'm going to start with 10 times 3. Once I've done that, I look around and I cancel numerators with denominators. Okay, so I have a 3 here. I can cancel that with that 3. I've got another 3 here. Cancel that with that. I have a 5, and there's a 5 and 10, so I have to go ahead and I have to break that down into 5 times 2. Now I can cancel that 5 with that 5. I don't have anything left now to cancel. Be very careful at this point. You can kind of forget things that are sitting around because it gets a little messy looking. You can miss numbers that were sitting there uncrossed out. What I'm left with is a 3 on the top in my numerator, just a 3, and I'm left with a 7 and a 2 on the bottom, and I multiply those together to get 14. Now it's fully reduced. I don't have to reduce it. That's my answer. That's my product, and it's fully reduced. Okay, so I find multiplying fractions to be pretty easy. All right, I am going to do division, which is almost the same as multiplication with one little step. Let's try 28 over 35 divided by 18 over 20. When we divide fractions, we turn that to a multiplication, and we flip our second fraction, just the one, not both, just the one. And so that's going to become 20 over 18. I'm going to make that 20 over 18. And now I'm back to the same process I did for multiplying fractions. I'm going to break these all down into a couple of factors. Start with whichever ones come to mind first. I could do 2 times 10 here. I'm going to do 4 times 5. I could do 6 times 3 here, or 9 times 2. All right, now I start canceling. So let me cancel these 3's. I've got a 5 that can cancel. Let's break this into 2 times 2. And let's break this into 3 times 2, because I've got a 2 that can cancel there. Let's break this into 7 times 2. Now my 7's can cancel. Let's see. Is that everything? I think it is. All right, so I end up with a 2 left here, a 2 left here, and I have 3 left there. And that's it. And so now I end up with 4 on top and only 3 on the bottom. Right, that's my final it's fully reduced, but I can make that into a mixed number if I want. It would be 1 1/3. That would be my fully simplified answer there. All right, so remember, when you divide fractions, turn it to multiplication and flip the second fraction. And don't forget to cancel your factors first. All right. I'm going to review something you all should know, like the back of your hand. That's supposed to be a rectangle. And that's a triangle, of course. I'm going to do square area. I'm going to stick some dimensions on this here. Simple basic reminder. What is the square area of this rectangle? The formula for area of a rectangle is side times side. And that's, we can see our two sides are 12 times 8. Whoops. And that's 96. We'll call that feet. Say it's feet. And my answer is 96 feet squared. Looking at the triangle, the formula for the area of a triangle is 1/2 the base times the height of that triangle. So that's 1/2 times 15 times 9. Let's see, I can multiply in any order. I'm going to multiply the 15 and 9 together first. That gives me 135. Oh, too bad I didn't pick a nice even number. Half of that is 67.5. Half of 135 is 67.5. And we'll call that also feet squared. Earth redeemed. Okay, so the Christmas music again. So the square area of that triangle is 67.5 feet squared. Those I'm pretty sure you know by now. Whoops, I don't want to clear the canvas. I'm just going to start there, show you how easy square area is, and then I'm going to go over volume here. So if you can do square area, you can do volume, like super easy. All right, so let's say I take that same rectangle and I add height to it. So I still have 8 and 12. Picture this same rectangle on the bottom there. So I still have my rectangle whose sides are 8 and 12, and now I've given it height, and my height is 10. So if I know that my square area of my rectangle is 12 times 8, and that's 96 feet squared, and I add the height of 10 to it, I just have one more step. 12 times 8 times 10. That's 960 feet cubed. Volume is always in cubic dimensions. So if you can do square area, you can do volume. It's just one more factor added on there. If you can do the side times side, you multiply it by the height and you're done. That's volume, right? Very easy. Oh, let me clear my canvas. All right. You know, I don't know whether we'll have a surface area problem, but just a review. Surface area is simply calculating the square area of every face of a right solid. This is clearly not drawn very well. Like I said, I don't do that very well. It's a little better, not much better. Picture this being a dice or cube of some kind. So surface area just means we calculate the square area of this face, the square area of that face, the square area of this, and then the area of all the surfaces that aren't showing. On a cube, there's 6, okay? And then we add them up, and that's the surface area, just as a reminder. All right. I will have a problem on order of operations. If you recall, that's what order we do our math operations when we have a very long number sentence with a lot of different things going on. Remember that we do our symbols of inclusion first. That's our brackets and such. Whoops. -4, this is a long one. Okay. We have both multiplication, addition, and subtraction I didn't do any division, but okay, so we start with our symbols of inclusion. All right, that's these brackets here. We go inside, we have to work what's in those brackets first, and within the brackets, I see I have some parentheses. So I have to do those within the brackets. I have to do my parentheses first. Well, this is 5, and then 6 plus 1 is 7. I'm going to keep my parentheses just to keep things cleaned up so I know what's going on. It might get tedious, but I do like to write everything else down to avoid errors. Okay, I still haven't finished everything in my brackets. I just did my parentheses. Now I have 5 times 5 times 7 minus 3. So I have to do my multiplication first. I have to do 5 times 5 is 25 times 7 is 175. And I still have to do my subtraction. All right. Now, at this point, I have parentheses over here at the end. I'm going to start working that too. I have to do what's in those parentheses. 8 minus 4 is 4. And then I'll do also what's in my brackets, which is 175 minus 3. And that's 172. I'm going to drop down my plus sign there. My 7, 15. Oh, sorry. This wasn't a 4, this was a 3. Okay, so where are we? We have multiplication here, and we have multiplication here. I have to do those first. 4 times 3 is 12. 172 times 7. Now, why did I do that to myself? All right, that's 49, 50. That's 12. Wow. I won't have numbers this large on the test. I just goofed. Oh, you know what? I didn't work this. I'm going to make this a nice even. Now that I see what I did to myself, I'm going to make that a problem I can work. We're going to call that 1300. Okay, so 1300 minus 1204. Now I can just go left to right. 1300 minus 1204 is 96. Plus 12 is 108. That's my final answer. Okay, that does get long and it gets messy, but I want you to go from top to bottom, doing just 1 or 2 operations at a time, writing everything else down just to make sure you don't forget anything or overlook anything. Okay, I'm going to do another one with, first I'm going to review exponents and radicals, and then I'm going to do another order of operations with radicals and exponents, because we learned that also. Okay, so if you remember, you probably understand exponents by now, but I'm going to review anyway. I'm going to write down various. Oh, we'll make this to the millionth power. All right, when we have an exponent right here, that means to take the base, which here is 10, and multiply it by itself that many number of times. So this would be 10 times 10, and that's 100. This does not mean 10 times 2. It's 10 times 10, right? Sometimes you know that it's 10 times 10, but sometimes if you're going too quickly, your mind just sees the 10 and the 2, and you multiply 10 and 2, and you get a 20. So just be careful. Just don't go too quickly. And always review your answers. When you take your test, work your problem, go back to the start, review your steps. Make sure you didn't make any small errors. So many points get deducted for small errors. Okay, 4 to the third is 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. 5 to the fourth is 5 times 5 times 5 times 5. We've done this in class and in another video. 5 times 5 is 25, times 5 is 125, and times another 5 is 625. 7 squared, or 7 to the second power, sorry, I didn't turn my phone off, I'm shutting those off, is 7 times 7, not 7 times 2, 7 times 7 is 49. Now my last exponent here is 1 to the millionth power. So I do that just for effect, just to make it clear that 1 to any number is just 1. 1 times 1 times 1 out to infinity will still always be 1, right? Don't make the mistake. You see 1 to the third power. It is not 3. It's not 1 times 3. It's 1 times 1 times 1, and it's always going to be 1. So that's a review of exponents. Now we're going to do the radicals, which sometimes you've heard me say multiplication is the opposite of division, or addition is the opposite of subtraction. Radicals are kind of the opposite of exponents. So let's write some here. It's this funny symbol that almost looks like a division symbol, but it has a little leg over here, right? We're going to put a little 3 in there and write 1,000. And then we're going to put 625. I'm going to put a 4 in there. So when you see a radical symbol, this is called a radical symbol, a radical. The way you read this problem is you look at the number underneath the radical and you say, what number, in this case, this is when there's no number here, this is called the index. If there's no number there, it's understood to be a 2, and that's the square root. So you would say, what number multiplied by itself gives me 25? What number multiplied by itself gives me 25? And we know that's 5. So the square root of 25 equals 5. When we see here, our next one, we have a 3 there as the index. So that means that's the cube root of 1,000. What is the cube root of 1,000? In other words, what number multiplied by itself 3 times gives me 1,000? And that's 10. It sometimes takes trial and error to kind of hone in on it. Oh, that number's too big, this number's too small, and you keep working inward and you find your answer pretty quickly. 10 times 10 is 100, times 10 is 1,000. So the answer here is 10. Cube root of 1,000 is 10. Okay, let's go to our next one. What is the fourth root of 625? What number multiplied by itself 4 times, this many number of times, gives me 625? Okay, and we just did that. I just showed you that 5 times 5 times 5 times 5 is 625. Okay, so the answer is 5. We would say the fourth root of 625 is 5. The cube root of 1,000 is 10. And the square root of 25 is 5. Right? That was a little messy because I was teaching you when you write your answer, just write it like that. Don't write it up here. It doesn't go there. What is the cube root of 1,000? That's 10. Don't write it up here. It doesn't go there. Right? So that's radicals and exponents. And now I want to do another order of operations problem, including some radicals and exponents. So first they taught you about order of operations. I don't know. I don't want to run into the same problem. I'm going to make that a bigger number. Okay, I wrote out my problem that I want to work here, but I didn't actually work it all out. We're going to start with 100. Hopefully that's good. Minus square root of 25. I'm going to put a bracket in, 5, and then we're going to put an exponent here, use the multiplication symbol, times 3, closing bracket, plus cube root of 64 times 3. All right, when we include radicals and exponents, their precedence comes after the symbols of inclusion, but before multiplication and division. So in other words, I have to work what's in these brackets first, and in these parentheses, that takes top precedence, and then I look at where are my radicals and my exponents. So let's do that. Whoops. Okay. So in my brackets, I have parentheses. I have to work that first. 7 minus 2 is 5. I keep my parentheses. And let's see. I'm going to go ahead and rewrite everything. And I'll work a couple of steps in one step, so this doesn't get too long. Okay, looking still at my brackets, I still have to solve what's in my brackets. I have multiplication here, and I have multiplication here. I have to do this exponent here. 4 times 4 squared, that's 16 times 3. And then 5 times 5 is 25. And then I drop down my subtraction symbol. And I keep my brackets to keep things clear what I'm doing. I'm going to go ahead and work my radicals here. I have the square root of 25, that's 5. And at the end of my problem, I have to do the cube root of 64, and that's 4. 4 times 4 times 4 is 64. Right, I did a couple steps carefully so that this doesn't get too long for you. You don't have to. You can do one step at a time if you want to and keep rewriting it. All right, I have to do this multiplication, and I still have to do what's in my brackets here. Okay, in my brackets, I have 16 times 3. Okay, class. I am going to change this. This will teach me to write out a problem and not have worked it first. Okay. Back to red. I have to make that smaller so that I don't get into negative numbers. I can work negative numbers, I just don't want to get into them here. Okay, so I changed that to 2 squared, that's 4. So now I have 4 times 3, and that's 12. Now I have 25 minus 12. At the end there, my multiplication evaluates to 12. Okay, still have my brackets. 25 minus 12 is 13. Now I'm going to squish this to a much smaller problem. One last multiplication, 5 times 13, that's 75. And now I'm finally left with just addition and subtraction left to right. 100 minus 75 is 25, plus 12 is 37. And my final answer is 37. So that was long and messy. When you work a problem with radicals and exponents, you still have to do your brackets first and parentheses. But after that, you're going to want to do your radicals and your exponents. Okay? And then you'll do your multiplication and division left to right and your addition and subtraction left to right. And I will not have one this complicated. I did a complicated one because I wanted to get all of the different math operations in. Okay, so the last thing that I want to go over is just the algebra, doing the solve for x problems, which is kind of just the quintessential algebra problem, solve for x. And this is a type of problem where we have x in a problem, and we want to get it in the form of x all by itself down the left equaling some number. So we find the value of x. And in class we worked both division problems, addition, and subtraction and multiplication. Subtraction problem. And we did this type where x is multiplied by a number. So your goal here is to get x all by itself on the left-hand side. I want x alone. In each of these problems, I want x all by itself, which means that the other number that's there with it, I have to get rid of, okay? I have to do something with that. I have to, quote, get rid of it. How do we do that? All right, let's start with our first problem here. X over 7 equals 8. X over 7 equals 8. X over 7 equals 8. This says X divided by 7 equals 8. If I'm dividing by 7, the opposite of division is multiplication. So I simply want to slap a 7 on there and multiply both sides by 7. By doing that, I can cancel this 7 with this 7, and I'm left with just X. And then I multiply my 8 and my 7, and what do I have? I have this in the form X equals 56, and I'm done. So I say something in class like we have to use the multiplication and division rules for equations. You don't have to remember that phrase. You just have to do the opposite. Okay, what if you're dividing by a number, multiply by that number. If you're subtracting by a number, add that number. Right, let's try a couple more. Let's do X plus 34 equals 92. This will be on your test. Will definitely be on your test. Okay, what am I doing here? I am adding 34. What is the opposite of adding? It's subtracting. And what did I tell you? Whatever number you have there, if you've added it, then subtract it. That's an underline symbol. That is not a division symbol. Okay, if I add 34 and I subtract it, I end up with 0. So all I have left there is X. On the right side of my equation, I have 92 and I subtract 34. That's 58. So X equals 58. All right. Let's do the next one. Next one is X minus 79 equals 17. Okay, I subtracted 79 right here. So what's the opposite of that? I want to add it. If I subtracted it, I want to add it. If I have a negative 79 and I add 79, I get 0. So it just cancels out and I have X all by itself. On the other side, I also have to add 79 there. Let me put my plus sign in the right spot, sorry. So now I just do some addition there. X is 96. All right. Let's do this one, which might be the most confusing. I don't know. It's not really confusing, but remember when you have a number, and our number is 1/3, right next to a variable here, it means multiplication. So let's remember, if I'm multiplying X by a number, I want to do the opposite to get rid of it, and that's division. So I can divide this by 1/3. If I take any number and divide it by itself, I get the number 1. So this cancels to 1. If I have 1x, I don't have to write the 1. It's understood to be 1. And then I have 15 divided by 1/3. That's 15. I'm going to write it this way, divided by 1/3. Let me make 15 into a fraction. What do you do when you divide fractions? Flip the second one. 15 times 3 is 45 over 1 times 1, which is 1, and that's simply 45. So my answer here is X equals 45. Fractions they're always a little more messy to work with. That is one way to solve this problem. Quick way, sorry. There's another way. It's multiplying by the reciprocal. I think, Sophia, you did it in class yesterday when you were solving this. So I can divide by 1/3, or I can multiply 1/3 by its reciprocal, which is taking that fraction 1/3 and flipping it. Okay? And then I would have to do that to this side also. So what is that? When I look at 3 over 1 times 1 over 3, remember how we can cancel these? Everything cancels out, and I'm left with nothing on the left but X. On the right, I'm left with 15. Put that over 1 times 3 over 1. That's 45 over 1. What do we get? We get our same answer. So there's two ways. If you're multiplying x by a fraction, you can divide by that fraction, or you can multiply that fraction by its reciprocal. That means the flip. Just invert that fraction, and you get the same answer. Either way, I'm going to get x equals 45. So if you're not clear on this, these will for sure be on the test. So just come back here and review that. I think, let's see, am I at the end? I think that's everything. If I was unclear, I apologize for the messiness of my order of operations problems. Maybe I should just do one more that's simple. 100. Let's do a really simple one. Minus square root of 16 times 3 divided by 2. There's a short one. Okay, looking at this, I have to work my brackets first. Within my brackets, though, I have multiplication, but I have to do this first. I have to do my radical before I do my multiplication. The square root of 16 is 4. 4 times 4 is 16. So now I have 4 times 3. And probably problems on the test will be a little simpler, more on the order of this type of problem than the other messy one I worked for you. Okay, so we still have to do our brackets. We have division here, but I got to do my brackets. So now I have 4 times 3, that's 12, divided by 2. And let's put my 100 back over there. Okay, I have to do my division here first before I subtract. 12 divided by 2 is 6. Now I can just subtract. 100 minus 6 is 94. No, wasn't that nice and simple? So make sure you do your radicals before you do your multiplication. Okay? Do your brackets before you do anything else. I think that's all I have. Okay? So be sure to watch this a couple times, or just skip around to the type of problems that you are a little unclear on. And I will be emailing out your final to your parents by tomorrow. Okay, class, have a great break. It's been a great semester.